Okay, let's play around with this new exclamation mark that has the definition in mathematics. Well, it's called a factorial. Let's see what it means. You saw the introduction, and now we do an example. 4 factorial equals 4 times 3 times 2 times 1. Go ahead and multiply that, you get 24. So you'll see that the factorial of a positive number is just multiplying that number down, starting with the number and then moving down 1 unit each step as you multiply. So we've got all the factors of 4, 3, 2, 1 multiplying them each other. Let's do another example. Let's see, expand 7 factorial. You notice I didn't say to calculate it. You don't have to give me a value after you do the multiplication. This is going to be a very large number, so I'm just asking you to expand it here. So we'll use the definition of 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. So you always stop when you get down to 1. You start at 7, multiply downward until you get to 1. Okay, now how can we use this? The reason we're being introduced to the factorial notation is because sometimes the terms in a sequence likes to use that as part of the definition of the term, the nth term. So let's use that. Example, given the nth term, a sub n, is equal to n squared over n factorial. Now before we go on, just take a look at that a sub n. Just like the previous example, that sequence, the nth term, in the sequence, a sub n, is defined in terms of the index. We just need to know the index and we can figure out what the nth term is. Now, what do they want us to find? Find the first 4 terms of this infinite sequence. So they're telling us it's infinite, but they only want the first 4 terms. That's cool. All right, solution. A sub 1. Well, a sub 1 has an index of n equal 1. So look back at the definition of the nth term. A sub n is n squared over n factorial. So a sub 1 is 1 squared over 1 factorial. Now, remember the definition of n factorial? It told us that 0 factorial is defined to be equal to 1, and 1 factorial is defined to be equal to 1. Both of them are the same. After that, you can just use the definition of multiplying backwards from that number till you get to 1. So the denominator here is 1 factorial. We know that's equal to 1. The numerator is base 1 raised to the second power. 1 times 1 is 1. So we have 1 over 1, which simplifies to the number 1. So the first term, a sub 1, in this list is equal to 1. Let's find the second term, a sub 2, using the formula 2 squared over 2 factorial. Okay, so 2 factorial on the bottom is going to be 2 times 1, and the top is 2 times 2, 4. Simplifying to 4 over 2, which is 2. The second term in this list, in this sequence, is 2. Let's find the third term, a sub 3. Now the index n is equal to 3 because it's the third term. A sub 3 equals 3 squared over 3 factorial. So that's 3 times 3 on the numerator, and it's 3 times 2 times 1 in the denominator, 9 over 6, which simplifies to 3 over 2. And the fourth term, which will be our last term, they only ask for the first 4 terms, is 4 squared over 4 factorial. That's 16 over 4 times 3 times 2 times 1. That's 16 over 24. And that simplifies to 2 over 3. Now let's draw a conclusion. I'm going to use the curly bracket set notation, but you don't have to put the brackets on it. I'm going to list a sub 1, a sub 2, a sub 3, a sub 4. They're all listed. They're in order. Remember, this is an ordered list of terms. So we have our positions indicated by the indices. And now I want you to try one. I'll give you a new definition for your nth term. I'll call it b sub n. Doesn't have to be a sub n. I'll call it b sub n equals 2 to the nth power over n factorial. All right, now I'm going to ask you to find the first 4 terms of this infinite sequence. So all you have to do is let the indices equal 1, then 2, then 3, and then 4, and you'll be able to use this formula to determine the value of each of the terms. So freeze the video, try it, and when you're ready, come back and replay it and see if you've gotten the correct answer. We've got, oh, there it is, 2, 2, 4/3, and 2/3.